Welcome, this is Network Academy, Basic Switching Concepts and Configuration. We are Andres and David. We are gonna learn how to configure a switch and how to configure them to adapt to different environments. We also see basic attacks that can happen in switched environments and many ways to avoid them. Basic switch is a device that can connect many end devices to one each other, so there is data transmission between them. After a Cisco switch is powered on, first it loads the post, that it's a program installed in ROM. The post is the power on self-test that checks the CPU subsystem. Next, the switch loads the bootloader. The bootloader is a program that is stored in ROM and immediately runs after the post. The bootloader performs low-level CPU initialization, which controls physical memory mapping and the quantity of memory and its speed. The bootloader also initializes the flash file system and then locates and loads the default iOS operating system. If there is a problem with the switch, we can always access to the bootloader. To access to the bootloader, we follow the next step. First, we connect a PC by console cable within the console port in the switch. Then we unplug the switch from the power cord. And then we reconnect the power cord to the switch and we wait 15 seconds and then press and hold the down mode button while the system LED is still flashing green. Finally, we continue passing the mode button until the system LED turns amber and then in green. And finally, we release the mode button. Now we are going to review the switch LED indicators. We have different LEDs on the switch that will tell us about the state it is found. First, there is the system LED, which shows whether the system is receiving power and is functioning properly. Then the redundant power system, or RPS, LED that shows the RPS status, which is an alternate power mode. The port status LED tells us if ports are working properly. Then the port duplex LED, which indicates if the port duplex mode is selected. Then the port speed LED, which has different combination of colors for every speed. Finally, the last LED tells us if the power over Ethernet is active. Now we are ready for preparing the basic switch management. To configure the switch, first we must connect it through the console cable, and then we can introduce the iOS command. For remote access, the switch must have an IP address with its subnet mask, and to connect to it from a different network, we must assign it a default gateway. Configure switch ports. We can configure switch ports in many different ways. There are two different duplex modes, the full duplex and the half duplex. The full duplex allows for a device to send and receive data at the same time, and half duplex is unidirectional. We cannot receive and send data at the same time. We can choose between full duplex and half duplex for our switches, and also we can set its max speed. Now we are going to see the Auto MDIX, which is the medium dependent interface crossover. It's a feature in the Cisco switches that enables us to connect either a straight-through or crossover Ethernet cable. Now we are going to verify the configuration of our switch. We have the show command, which can tell us many important things about the switch. For example, we can know if the interface is up or if there are problems such as ground frames, which are Ethernet frames that are shorter than 64-byte minimum, the giant, which are Ethernet frames that are longer than the maximum allowed, and CRC, which indicates a media or cable error, or if there are collisions. Now we are going to review the Secure Shell, that it's a protocol that provides an encrypted management connection to a remote device. It should replace Telnet for management connections and provide security for remote connections by providing strong encryption and authentication using a username and its password. Now we are configuring Secure Shell in our command line. The first step is to verify the Secure Shell support. Second, we configure the IP domain. Then we generate the RSA key pairs. Then we configure user authentication by username and secret password. Then we configure the BTI lines. And finally, we enable the SSH version 2.
Now I'm going to talk to you about another important part, which is security. There are many ways to attack a LAN. One of the most common ones is MAC address flooding. In a network, when a switch receives a frame, it stores the sender's MAC address in a MAC address table for future use. And when he doesn't know where the destination MAC address is headed, he floods the network. He sends it to a broadcast to all of the computers in the network. Now, attackers use this behavior and send frames with random MAC addresses for the purpose to fill the MAC address table of the switch with random MAC addresses. And when that happens, the switch enters a fail open mode. In this mode, the switch broadcasts all frames to all machines on the network. As a result, the attacker can't see all of the frames. Another common security attack is DHCP starvation attacks, in which the attacker sends many DHCP requests to the server, so it has all the IP addresses the DHCP server can give, and the real users can access the network, which causes a denial of service. There's also DHCP spoofing, in which the attacker creates a false DHCP server and gives the users DHCP addresses so that their default gateway is now the attacker's computer. Another attack that only affects Cisco devices is leveraging CDP, which stands for Cisco Discovery Protocol. This protocol broadcasts information about the sender, such as the IP address, software version, platform compatibilities, so that nearby Cisco devices can auto-configure themselves to make connection easier. Attackers can also see this information and use it to exploit switch vulnerabilities. Also, because CDP is not authenticated, attackers can send bogus CDP messages through the network and affect various Cisco devices. Another most common attack is the brute force password attack, in which the attacker uses a dictionary to try to establish a telnet connection with the switch, and if that doesn't succeed, he tries to create a sequential character combinations in an attempt to guess the password, and that's why it's called brute force, because it tries every combination possible to try to discover the password. And now, with all of these attacks, you might be asking yourselves, what can we do about it? Well, there are common several practices for securing a network, which are develop a written security policy for the organization, shut down unused and services and ports, also use strong passwords and change them often, control physical access to the devices, perform backups, and test the backend op files on a regular basis, and also encrypt all passwords and sensitive data. Another thing we can do is to enable port security. One of the simplest methods is to disable the unused ports with the shutdown command. Also, we can shut down many ports at once using the interface range command. Another important measure we can take to prevent these attacks is to enable DHCP snooping. What this does is to classify certain ports as reliable, as secure, so that only these ports can send DHCP responses. And when someone tries to send an DHCP response and it's not classified as a secure port, that port is automatically shut down. Another very important thing we should do to protect our network is to enable port security. What port security does, it limits the number of valid MAC addresses allowed on a port. These MAC addresses can be static, which are configured manually by commands. There's also dynamic MAC addresses, which are configured dynamically. There's also sticky MAC addresses, which can be dynamically learned or manually configured. Also related to this, there's violation modes. That's what happens when the maximum number of secure MAC addresses has been added to the address table, or when the same MAC address is twice on the same VLAN. There's three kinds of violation modes: protect, restrict, and shutdown, which is the default. And finally, we have the network time protocol, which is a very useful protocol that synchronizes the clocks of computers over the same switch network so that we have correct timestamps to accurately track network events such as security violation. And this concludes chapter 2. We strongly recommend that you read NetAcad so that anything that we have missed you learn, and to practice these commands because they are very useful. And that's all. Thanks.